Greetings and welcome to another installment of Easy SPSS. I'm Dr. Gross, and today I will run you through the Wilcoxon signed rank test, a non-parametric test, kind of similar to a t-test. Let's look though at our data set for this. If you have it saved somewhere, you would open it through this folder button. And you can see mine was saved right there. I've also got it saved on a jump drive, but wherever you have it saved, go ahead and open it up, and you should have variables up to, I believe, here. And I have added some variables for our next 3 tests that we'll do in this video series. But we'll discuss and add each one as we go. Let's just go over real quick again. This is data view, where we have our cases or our participants in the rows and our variables on our columns. And this is kind of like our spreadsheet. In variable view, you can see all of our now 15 variables. I believe we had 10 before, or 9. Oh, we had 11. 11 variables, and I added those 4. But in this view, you can see all the different variables and then the characteristics of those variables. Labels that will add values if they're coded, missing values, which we discussed last time, but we have some this time, and the measures of these as well. So that was our quick overview of data view and variable view in SPSS. So let's look at this test, the Wilcoxon signed rank test. So what you're doing is you're trying to compare groups, right? It's kind of like a t-test, but you're not comparing the averages or the means, because t-tests would assume normality of the data. However, we are using this test because hypothetically our data is not meeting those assumptions of normality. So we can't appropriately use a t-test. So in this case, we can appropriately use a test that's designed for data that doesn't necessarily meet those assumptions of normality. And so the Wilcoxon signed rank instead compares medians instead of averages by ranking each person's change and then seeing if the sum of the positives versus the negative ranks differ. Hopefully that makes more sense as we get into it. So the variables that we'll use today are weight, which we already have. And then we'll add a variable today, and we'll call it our mid-exercise program weight. And we won't have any missing values for this, so we won't have to do anything in variable view as far as missing values goes. But let's go to variable view, and I believe your next row that you should have blank is row 12. So on row 12, you'll enter in mid-exercise program weight. Remember that SPSS doesn't allow for spaces, so I've got underscores here and here. When you've got the name under type, we'll say it's numeric. These will auto-generate. I kept the decimals at 1. That's fine. Now on the label, I said midway exercise program weight. And so let's say our participants are engaging in an exercise program, and we are testing them at the beginning for a baseline measurement. And then midway through, we'll test them again, we'll weigh them again. And then after the exercise program, we'll weigh them another time, a post-exercise weight. But this variable we added for another test, so we won't do it this time, but stay tuned. So to keep going with this variable, no values for this one. no missing values, and it is a weight, so it is a scale variable. Now, I'm gonna go over to my data view so that you can see this mid-exercise program weight, and go ahead and pause the video right here. And after you've entered that variable in variable view, we'll come back here to data view. Go ahead and pause it and then enter in these data for mid-exercise program weight. All right. And now that you've had time to pause and enter that in, let's go ahead and running the analysis. So we'll go to Analyze, Non-Parametric, Analyze, Non-Parametric, Legacy Dialogues, two related samples. So I've already got my pairs in here, but let's say they weren't. First thing that you want to do is make sure that Wilcoxon, the test type, is selected, which it is. So if it was not, we select it. Now for our pairs that we want to compare. For pair one, we're going to say weight, right? Our original weight, baseline weight. And then our midway exercise weight. All right, so weight is variable one, and then mid-exercise program weight is variable two. We're going to click Options. And then just make sure that descriptives and quartiles are checked. We click Continue, and then we'll click OK. And we'll run the test. So let's take a look at the output. And you'll see a few things. You'll see the descriptive statistics table here. It is showing you that there were two missing pieces of data, or two participants. So our in value for weight is only at 30, while our number of participants for midway exercise program, all of them had data for that. So 32 would be the number of participants in there. And it's giving you descriptives on these groupings, right? So the total weight of all participants, and the average of that, standard deviation, the median, which is what we're measuring. And then again, taking all those participants, all 32 of them, 30 of them the first time, taking all 32 participants and saying, okay, all 32 of them, the average weight is this, but we're not looking at averages, we're looking at medians. And so 132 and 131.4 is pretty close. So I would expect not really a significant finding there. And you saw that baseline 132 and 131.4 right there. So that's why we included the quartiles. Sure, first, second, and third quartiles, and your 50th is your median, right? It's your middle quartile, your median. And the median for groups in the beginning, the pre-weight baseline was 132 pounds, and midway through the median was 131.4, so not much of a difference. In the Wilcoxon ranks table, so the ranks table is right here, you can see that the number of negative ranks was 13. And the number of positive ranks was 17. And then the sum of those rankings here. Now, the A and the B, the negative ranks. This is midway exercise program weight was less than the weight in pounds or baseline weight. And so um, if this were the case, it counted 13 of those. And 17 cases where the midway exercise program weight was greater than the original weight, right? So you can assume from that some people gained some weight during the exercise program, or at least the first half of it. The final table is these test statistics table, stuff to say, and a z-value of negative 0.031 and a p-value, this is your p-value, of 0.975, which is not significant, not less than 0.05. And so what you would say is, in this non-significant test finding, simply put, your p-value near 1 tells you that there's no evidence that the median weight changed by mid-program. And you can see that represented in the median values, 50th percentile, the 132 up here. At the 50th percentile, your median weights 132 and 131.4. I mean, they're pretty much the same thing. So not much of a change in participants' weights from the beginning of the program to midway through the exercise program, is how you would interpret and state that. So hopefully the Wilcoxon signed rank test made sense there. It's basically a t-test. You're comparing the groups to see if there was a change or a significant one. But in this case, you can't use the t-test because the data did not meet the assumptions of normality. And so you would switch over to this test, which is more suitable for that type of data. This is Dr. Gross. Hope you had a good time. Stay tuned for our next easy SPSS tutorial.